Mercury looks like the last place humans could live. But if you judge planets by energy, resources, and where people actually stay alive, Mercury turns out to be unexpectedly strong.
Welcome to Istrotech, Moonbase Lappträsk, and the Settler's Guide to the Solar System, starting with the Settler's Guide to Mercury. Mercury is number 1 from the Sun. It has a gravity of 0.38 of Earth gravity, which is exactly the same as Mars and about twice as much as the Moon. Should be sufficient for human existence without issues. Not quite certain, but probably. It has a day of 6 months, and the day is the important bit here. It says when the sun goes up, when the sun goes down, and how long time you need to store energy, 3 months. The year is 3 months. So the year is half a day, which is a bit odd for us Earthlings. But that's the way it is. And it is exactly half. The year is exactly half of a day. And that is because the rotation of the planet is locked to the orbit, which is highly elliptical. That the orbit is highly elliptical means that the energy input varies with a factor more than 2. So it goes from about 5 to about 10 times what the energy input is on Earth. So plenty of energy on photovoltaics. Problem with plenty of photovoltaic energy is that there's also plenty of radiation. So you need to dig down deeper for the settlement than any other place. The temperature can reach 100, 200 degrees near the equator. Average. It is several hundred degrees in the late noon. So you need to go underground. At the poles, it can be down to a couple of hundred degrees minus, actually. I'm writing minus 90 here, which is close to the poles, but not in the permanent shadow craters. And resources. Metals and minerals. There is plenty of metals and minerals and ores and quite varied composition on the surface throughout Mercury, so it's probably possible to get most things if you search a bit. However, it's low on iron and titanium. We know that, or rather we believe that, because measurements indicate that. Volatiles in permanently shadowed regions, there has been quite strong indications of water. The estimate is about up to 1 trillion tons of water, which is more than on the Moon, slightly less than on Mars. No nitrogen has been detected. Essentially no nitrogen has been detected, which is a really bad sign. There are some possibilities still open, nitrogen compounds that would not have been detected on the instruments currently used. And there could possibly be nitrogen underneath the ice by the poles in form of ammonia ices. Underneath the ice cap in the permanent shadow region, the temperature should be sort of cold enough to handle nitrogen. So resources, sort of okay-ish. Plenty of other volatiles, actually, not only in the polar region but also in the soil. Transport. It is Mars level. You can get there with cost and time as it would be to Mars. You can also go faster if you spend like 3 times as much fuel for that and skip a bit of cost-saving mechanisms. So, taken together, there are drawbacks, nitrogen and some metals, but it is a surprisingly good candidate for settlement in the solar system.